Hi, everyone. Okay. It's great. Hi, everyone. That's the last presentation before lunch. And be careful. Strange things can happen. For example, this chicken wings restaurant in US couldn't serve chicken because they got attacked with ransomware. So this is one of the things I will talk about today. It's about expecting the unexpected and basically trying to forecast what can go wrong with your systems and your application. Like, who could predict that you could not serve chicken because of ransomware? And I've got a few examples like this. After my presentation, the organizers will ask me to copy my presentation on their USB drive, and I'm supposed to plug in their pen drive into my computer. Well, who stops them from using a rubber ducky, a software that emulates a keyboard, and just type random things on my computer? Now, what stops me from taking their pen drive, changing it to a rubber ducky so that the next presenter gets infected with my malware, right? There are a few questions. Oh, the next one. Who knew about the Logitech vulnerability? Who knows about it? 1, 2, 3. All right, there are like 5. I just found this here. And this is a vulnerable clicker. What happens is that you put this USB port into your computer, and you can change the slides with this. Well, I will not plug in a clicker. I'll just stand here just because they are vulnerable. And I can intercept the traffic between any computer and the Logitech clicker, inject anything into this communication. So not only changing slides, but this works as a keyboard. So I can practically inject any keystrokes into their computer, which means I practically own their computers. That's great. So we'll talk about today about, as I said, expecting the unexpected, so the Spanish Inquisition, and thinking about what can go wrong with your systems, with your application, with the hardware you're using, and any other IoT devices. I will introduce you to the concept of threat modeling, which is also evil brainstorming. So this will be an activity to think about what threats apply to our application, what can go wrong, how to defend against those threats. And I'll just mention a quote that from Jim Manico, one of the guys in the security industry, that every software engineer or test engineer is a security engineer now, because the stuff that you produce, the stuff that you develop, basically needs to have some security level. Okay, so a few things about me. Well, I worked quite a lot of time in IT and security. I worked here and there, recently in Australia. So here is me and my mate, the gangsteroo. Now I moved back to Poland, and I'm seeing that practically every industry all around the world is the same. The companies, even if they introduce some testing and they check the quality of their code, they're not doing this from the very beginning. So today I will talk about how to care about the security from the very beginning of the process and of the design process of your applications. Okay, so how does a typical SDLC process look like? We've got the design, coding phase, testing, release, maintenance. The functionalities, they get designed, they get coded, tested, released, and maintained. Now, this red one thing here is a bug. When a security bug gets into production, it's bad, right? I mean, it's costly. What does it cost to fix a vulnerability? It depends. It really depends. And the same type of vulnerability can have a different cost. So, for example, I'll talk about the same vulnerability found in 3 systems. The first one is weak encryption in a web application. What does it take to fix a weak encryption there? Just like one line of the configuration that you need to change on the server side, right? What if there is a weak encryption in a mobile application? You need to recode the mobile application, build it, push it to Play Store or the Apple Store, and then the clients they need to update the version. And for some time, you need to be compliant with the previous version, right? So it takes a lot of time. It is costly. Now, the third one, we've been testing some corporate printers. You probably have one of those in your office. That instead of just printing to the device, you print to the print server, then you swipe your card, and you collect the prints at the printer, right? You have those. So we found that at the back of this printer, there is an SD card. On that SD card, there was a jar file with a Java application for the embedded device, which is the printer. And it had some software. So we decompiled the software, and we found that the files between the printer and the print server and the workstations, they're encrypted, but they're encrypted with a static key, static encryption key, AES, and it's the same for all of the printers. So it's bad. So we submitted it to the vendor and to the bank that we've been testing there. And they said, guys, all right, well, that's a solid vulnerability, but to fix it, we need to manually go to each printer and change the SD card software because there is no remote firmware update. So it is costly, right? And it is even more expensive because in this case, the same vendor had the same encryption key for all of the printers in the world that they produced for every client. So like tens of thousands of printers. So it is costly. Now, cost to fix is actually not everything. So the cost of a production security bug, there are a lot of components there, right? You need to do some incident response if your AWS EC2 instance got compromised, right? You need to do risk assessment. Does it actually affect our pipeline? Does it affect our business? Do we need to fix it? Then the actual fix. And once you put a fix on production or in the development environment, before it gets to production, it needs to get tested, right? Ransom, like in case of ransomware, GDPR fines, they're more or less the same. In Poland, we had this case some time ago, the Morele.net. Have you heard about this? 3 million zloty GDPR fine for not being compliant with the new rules. And reputation impact. How many of you heard about the Equifax hack in 2017? Hundreds of millions of American customers' data was stolen, and well, their stock value got heavily damaged. So the stolen data, what is the cost of the stolen data? There is no cost, right? You can't, once the data is taken, you can't untake it from the attacker. So this is priceless, right? So we want to avoid security bugs, right? I hope you want to avoid security bugs as well. What else can go wrong? I really invite you to read this article about the cryptojacking attack at Tesla. So they had a Kubernetes console publicly available with the default password. So somebody just guessed the password because it was the default one. They tried a few. They logged into their Kubernetes console. They had some AWS credentials there. They put a crypto miner, and they've lost like $100,000. Another one of the companies in the recruitment process, they asked the candidates to deploy an application to get a job, and if they deployed it in a good way, they got a job. So one of the candidates, and the company was giving out the credentials to their test instances on AWS. One of the candidates, they've put their code on GitHub, on the public GitHub, and it contained the AWS key. So somebody just found this key after 2 minutes. So the compromise happened 2 minutes after this person uploaded code to GitHub. After 2 minutes, they installed the cryptojacking, crypto mining instance, and what? $91,000. So beware of that. Okay, with the forecast of $130,000. So we want to avoid these kind of bugs. So we are introducing security testing. So we catch the bug during the testing process. It gets back to coding. Once it gets fixed, we can go back to the release and maintenance, right? This is nice. I mean, security testing is good. This is what I'm doing for a living. I break into banks and they pay me for it. But think about number of security of issues in time. If you didn't have security testing, the number of issues will just rise in time. Why? Because there is no metric to enforce the development to actually fix some bugs, and they are not found. So the number of issues just rise in time, right? After you introduce one round of penetration test, you expect some results, right? And more or less, this is not. There are no numbers here. This is not taken from any scientific research. It's just a assumption. It actually works pretty well. So you expect that after a first round of testing, you will find some issues and they will get patched. This is the first line that goes down. But then the issues will get reintroduced, or some new issues will happen, and you can expect that the number of issues will then rise. So what do? You introduce few rounds of security testing, and you expect some better results, right? So you will find some issues, they will get patched, some of them will get reintroduced. but then after 5 rounds or few, or like 1 round per year, you expect some good results. And this is what most companies all across the world are doing. They're introducing multiple rounds of security testing because it works well. It is pretty good. But we want to go better. We want to do better than that. We want to start from as less bugs as possible, then find as many as we can during the penetration testing rounds, and then do not introduce a lot of them in the next rounds of development. How to do it? So if you look at the single penetration testing round, you can see some of the numbers here. So how many bugs there are in the very beginning in the development process, that's the quality of the design. How somebody designed this application, was it like secure by design or not? Then the number of issues that you find during the penetration test, that's the quality of testing, of course. And the next one is the quality of coding. So what do we want to do is we want to affect all of those parameters to get the best results. And there are tools and services for that. There are a lot of options. Probably your companies, they have a lot of these tools, the vulnerability assessments, web application firewalls, static code analysis, dynamic code analysis. There is a lot on the market to offer. But many things can go wrong as well, and we've seen it. So for example, allowing only trusted dependencies. Do you use this kind of software like software composition analysis, Nexus, or Sonatype stuff, SNCC? Okay, right. We've seen at one company a proper security process that allowed the developers to only import libraries from Nexus, which is totally good. But Nexus allowed to import any library from Maven Central. And of course, you can put any library into Maven Central as a random developer. So in the end, there is a restriction that you should be allowing, you should be importing only trusted dependencies, but you can import practically everything. We've got static code analyzing tools, right? Sonatype, Fortify, whatever, check marks. That's good, but have you implemented this as an opt-in or opt-out? Are all of the projects in the process of checking by SAST? Is every release checked by a static code scanner? That's the question. And the next question is, what happens when a static code analyzer finds a vulnerability? Does it alert the developer? Does it stop the build? And that's a good question. Does it stop the build? And the next thing is that practically in every company we've seen that had SAST software, static code analyzers, it doesn't stop the build because the developers complain that, oh, come on, it cannot stop our pipeline. It will stop our work. Regular vulnerability assessment scans. Well, that's good. Like, there are a lot of software on the market. To enable Nessus, there is Rapid7, etc. That's good, but unauthenticated Nessus scan will not find a obsolete Java Struts library. So there are a lot of things that can go wrong when introducing those kind of tools and services. And tell me, you've got online banking, and this function prints the transaction by account, and your account is 1234. Which tool will detect the vulnerability that I changed 1234 to 1235, which belongs to the other client? There is practically no tool on the market which will detect this. So we need to find these kind of problems during the design process. So what to start with? And the idea I'm suggesting is to start with threat modeling, of course. That's the quality of the design. It will also help us to focus on something during the training phase. And it will actually define the scope for the penetration testing. So here's how it works. You need to affect the quality of coding. You need a proper training. And by proper training, I mean not showing the developers how they can attack the application. It's like, do you know this sketch by Monty Python? It's like, yeah, somebody can attack you with SQL injection. Or I can show the developers how to attack with SQL injection, but it's not their job. Their job is to code securely. And they need training in secure coding, not in attacking the web applications. Okay, so the quality of coding is a good secure coding training and onboarding on standards. If you have 100 or 200 developers, there is some rotation. You employ 5 or 10 new developers every month. You need to the time they are starting writing the code, the first line of code, they need to be already after the onboarding security training. And we need to have some security requirements. And this is the thing. Got actually a question to you. In your companies, in the software that you develop, or in the systems, the infrastructure, have you seen the security requirements? Who has seen security requirements? Okay, that's around 10 hands. It's around 100 here of you. It's confusing, right? Okay, so we'll talk about how to define the security requirements. Next thing, we need the quality of testing. So we need adequate scope and test cases for the penetration test, for the security test. Maybe we can use some of those test cases in the QA process for the functional testers. We'll see. And the next thing is the quality of the design. And here is the thing that I'm introducing, so the threat modeling. Now, I'm guessing that most of you work in more or less agile environment. It's not like full waterfall anymore. Things were much easier in waterfall. Because what? We could have some secure design, then we go to the next phase, we've got secure implementation, security testing, there's time for that. We're giving the developers another few weeks for the fixing, and then we can go to production, right? With Agile, I really wanted to put some funny Agile meme here, but we'll probably, as most of you work in Agile, you could be against it. Some Agile fans here? No, all right. So with Agile and security, it's much different. The functionalities also, they get designed, coded, tested, released, maintained. There are some bugs there, but the moment we can think about next things, there is the second sprint, third sprint, fourth sprint. I didn't even manage to talk in time. So there is practically no time to focus on security testing, and we cannot stop the system at one point and do 2 weeks of penetration testing, because during those 2 weeks, there'll be like 150 changes in the system and maybe 2 releases. So another question to you is, when does your security, if you have a security team, when does your security team show up? During the design, coding, testing, release, or maintenance? Maybe let's do a quick guessing. Those people who have security team joining them during the design of the system, put your hands up. Okay, a few. Okay, and then when coding, can you ask your security team, hey, how could I securely code it? All right. Testing, supporting the testing, and before release. Most of you, they get security team before the release. Yes, because that's when the security team can say, okay, you've got green light to go to production or not. But the moment there, you've got a lot of bugs to fix. So let's talk about an example company. They've got 10 teams. Sprint every 2 weeks. That means that in a month, they've got 20 sprints. In each sprint, they've got like 30 user stories. So in total, 600 user stories per month, which translates into 1,000 code changes, including the security and hotfixes. And when this gets decomposed into the tickets, it is around 3,000 Jira tickets. So where the security team should start? Check every Jira ticket, every code change, secure code review, every code change, 1,000 times a month. Let's do some simple maths. With, say, 600 user stories, you want to spend 1 hour on testing each user story. That's 600 hours per month. That is 5 full-time pen testers. No way. Sprints? Okay, 20 sprints. You want to test 1 day for every sprint. This is 20 days per month. This is good. This is 1 full-time pen tester, right? But everything needs to happen on every second Friday. No way. Okay, so I've mentioned the decomposition of user stories, and this is the part where you could start. Imagine this story. User downloads a list of transactions and their details in online banking, for example. This gets decomposed into 2 API functions. One is get transaction by user. The second one is get transaction details. Maybe those 2 tickets will be developed by 2 different developers, and they write quite a good code. One of them prints the transactions by user, the ID of transaction belonging to an user, and the user is taken from the context. And there are 3 transactions there. And the second person writes an API function that prints transaction details based on the transaction ID. And joining those two functions, you can create the user story, the epic, which is the user downloading a list of transactions and their details, right? First they have a list of transactions, then they click details. Nice. But what stops the attacker from changing 123 to 124 here? 124 is not on that list. We've got a security vulnerability here. So the suggestion is you could start with redesigning the user stories. Okay, I'll just skip that. This, all right, never mind. Okay. So we want to introduce security to the Agile environment before the stories get designed. And how to do it? And so here's the thing. It's not that I'm a threat modeling evangelist. It's a simple calculation. It's a simple calculation because it works. It works, and we're doing this on a daily basis for our clients. We're doing the threat modeling sessions. We're doing threat modeling trainings. We had a company that introduced a smart gate for their factory, and it was scanning the license plates of the trucks that were coming into the company, and they're allowing only those that they should be allowed through. And they almost implemented an SQL injection in the license plate. The other company was thinking about physical access control, and they almost bought a physical RFID card based on MyFair Classic. MyFair Classic can be cloned with any Android device just by swiping in the metro system, right, or on the street. And we're doing this for the AWS clouds, for Azure AD, and it works, because then we have a list of threats. Based on the list of threats, we can go to the security requirements, and we can make the development more secure in the very beginning. So what is threat modeling? And this is like the key slide here. Threat modeling is thinking about what can go wrong. Thinking about who can attack the application. That is the threat actor. For example, an anonymous person on the internet. Or maybe your employee, which is a malicious employee. Do you care about them? If you don't care about the malicious employees, then you just ignore this threat, and it's all good. Then, what can go wrong? So the user is downloading data of other users, or the user gets is downloading the whole database backup, for example. And then the third part is thinking about technical ways of how this can happen, and these are the attack vectors. So how in detail this can happen technically. For example, in the previous example, there was this API call by changing 123 to 124. This is the idea. Once you have the attack vectors, you can go to the security requirements by simply negating the threat. So if the threat is one user in online banking is downloading transactions of other users, the security requirement is in this function, one user should not be able to download the transactions of other users, or the system should check whether the transaction belongs to the current user from the context. Then if we negate it one more time, we've got a test case, which is more or less a technical implementation of the attack vector. And these test cases, if they are formally written down, they can be used in the QA process, they can be used in the penetration testing scope. It's very useful. The question is, does it work? Well, generally, yes. Secure by design works if we think about all security requirements. The thing is that, especially in Waterfall, it was very easy to implement, to think about the security requirements, because the dev or the DevOps could give the DFD diagrams and the functional requirements to the security architect. The security architect could refer to them with the security requirements or with the testing scope, and he could give some go-live decisions. In Agile, it's not that easy, right? What? You would need a security architect for each team. Let's go back to the example company. 10 teams, they need 10 security architects for 100 developers. No way. So maybe one security architect serving few teams. Maybe you just need 2 security architects for 100 developers. Well, that's also an idea, but it doesn't scale well. So practically, the only solution to scale the security well is to delegate some of the job to the DevOps and make them the DevSecOps, right? You want to become DevSecOps, right? And here is how you can implement it in your company or in your processes. You've got the list of user stories or the functional requirements for the system, for the infrastructure. You need to take a decision which threats you should model and which not. Some of the stories, they affect security, some of them not. I'll mention that in a moment. Once you've got those stories that affect security, you need to do a simple threat model. And once you have the threat model, the security requirements, you need some follow-up. So either do a penetration test or check with the developers they follow the security requirements. Okay. I mentioned that some of the stories, they affect security and some of them not. I will give a few examples, and I want just to for you to vote whether you would model the threats, whether you believe that this story affects security, and you would actually model the threats. So the first one. The change is cosmetic changes to the report template. They just change colors from blue to red. Who would model the threats? Okay, nobody. Good. GDPR pop-up. By clicking this, you accept for us to collect all data on you. Okay, nice, few. Update jQuery library. That's a good one. But at the same time, you should think, why would a person update jQuery library? Probably because there was a penetration testing report which mentioned it is obsolete. Okay, next one. Change randomness in a reset password link. Okay, I love that. There are a lot of vulnerabilities in that functionality. New authentication provider. Okay, almost everybody. And a new report type, list of transactions per user. Cool. Okay, that's good. Here is what I wanted to mention about different wording of user stories. What if the story user downloads transactions of other users, user downloads a list of transactions and their details, was renamed, and in Jira or in the documents, it was specifically mentioning the security function. Like user displays a list of their own transactions. It's obvious, right? But here maybe the developer will think, yeah, their own transactions, I need to introduce some access control and details for each of their own transactions, because we don't want users downloading other transactions. Now, update jQuery library. What if we write update jQuery library to the newest available version without vulnerabilities? Now we don't need to model the threads for that story, and the developer will know that they need to do exactly like that. Okay, and now we need to move to the actual threat modeling and writing down the results. So here is my proposal how to do it. We've got a user story or a functional requirement or a part of infrastructure, and we try to think about the abuser story. Abuser story is like the evil way of thinking how would you exploit this scenario, and you don't really need technical knowledge on security to actually think about those abuser stories, right? For this, we can think about that one user can download transactions of other users. Security requirement, as I mentioned, is the negation. So we've got that the transaction should belong to the user from the current context. And then the test case will be checking the access control across the users. Now, are there any other abuser stories? Of course. You can think about technical attack vectors by injecting SQL or XML into the ID field, right? Or the executing this function without authentication. So we just grab the API method and we call it without the session cookie. But all of those, they should be covered by the base threat model. And the base threat model is the next concept, is that the whole API consists of very similar methods. They implement different functionalities, but they have the same structure. And for the SOAP API itself, we can write some base threads. And the base threads are injections of XML, injections of SQL, executing without authentication, forcing a cross-site request forgery. Now, with managing all of those on the SOAP API level, we don't need to model the threats for the specific functionalities because it's all covered by the base threat model. And we have the security requirements here, so that all of the functions, they require authentication, that for the XML, the external entities are off, typecasting, prepared statements for SQL injection. We cover all of those in the base threat model. And we can stack the base threat models. So SOAP API is written in Java Spring, for example. We can model the threads for the Java Spring, and we can have some security requirements, some specific configuration options that need to be turned on and turned off. And this is good. Once we have the base threat models, we can go to the specific functionalities and there design the abuser stories. So how do we add another S to, which means security, to the software development lifecycle? We have some initial discussions. We define the base threat models. Then for the stories that affect security, we do the abuser stories. And at the end, we've got the testing phase where we have the security metric. We've got the test cases for the security testing. Who does what? For designing the base threat models, you need the security team or some external security company that will actually think about those specific security scenarios for the base threat models. The abuser stories can be totally, with some help on the very beginning from the security team, they can be designed by anyone, like by developers, by project owners, by business analysts, by architects. And then during the testing phase, you can delegate some of the testing work to the QA, to the functional testers, or do it by the security team. Okay, and now I will do a reverse life hacking session, which is quite funny. Because it will not be me which will be showing the hacking, it will be you hacking the applications I show you to prove that anyone can think about security and design the abuser stories. So, first example. We are at the airport, and you know there are those business lounges, right? And to get into the business lounge and drink booze for free, you need to show the business class ticket. Not everyone has it, so here is the business class ticket and the economy class ticket. What would you do? Oh, sorry, I forgot to say. At the entrance of the business lounge, there is the QR code reader. There is no person there. It's just a QR code reader. You put your boarding pass, it says, OK, you can go through, or it says no. What would you do? How would you hack this QR code reader? You have an economy ticket only, and you need to go through the business lounge. Change the QR code. Correct. It is a vulnerability within the QR code system that just a part of the QR code defines the class. So we can change it to business, and there is no signature on that, so it works. OK, great. Another one. Yep. Tailgating. Yep. Why not? You will just tailgate after somebody. So use somebody's other card. Yep. Good luck with that. More than one time. So you've got your colleague, which is who is a manager, and he gets the business class. You not, because the company is a cheap ass. Yeah. Use an old ticket. Good. So you flew business a month ago, and you're using that one today. OK. So practically, on the next slide, there are all of the stories that you mentioned. And it is really simple. You've got the old business boarding pass, using one boarding pass twice, use of scan of a boarding pass, so somebody else's. Oh, sorry, from another airport. That's a different one. So the QR code reader should check whether the ticket is for this airport, because you could have a friend flying from another airport and copy his boarding pass. And modifying the class in the QR code. Easy, right? And we can define the security requirements, add it to the development, and maybe it will be secure. OK, another one. You're earning money in the advertisement industry, and you've got some balance there. You collected $1,000 from the system, and you want to withdraw it. And in the withdrawal function, you've got the number, how much you want to withdraw. Remember, you've got 1,000 in your account. And from the drop-down list, you select from which account, to which account should be the wire transfer made to. How would you attack it? More than the balance, yep. Modify the drop-down. So, yep, changing the account to somebody else's. You can hack somebody's account in this system and withdraw it to your bank account. Yep. Integer overflow, yeah, like technical attacks on this field. Yep. Yep. Do you work in security? That's a good one. Yeah, you can intercept requests and try to tamper with that. Maybe you can change the sender account. And all of those attacks, they existed in real systems. Like imagine that with that attack, you practically hacked one of the Polish online banking system a few years ago. The Polish stock market, you could just, withdraw more than you had on the account balance. You could send a wire transfer from somebody else's account. These kind of bugs happen. Okay, so we've got a few of those. So withdraw more than your balance, select an account outside the list, make somebody withdraw money with cross-site request forgery. Now, I crossed out this one, so withdraw negative amount. I don't know if we didn't get to it. What if somebody sends a negative amount, right? Actually, this one was in one of the online banking systems. When you send $5, $5 is taken from your account and sent to somebody else, right? What happens if you submit -5? Yeah, and the system cannot send -5 because it is a cross-bank transfer, but it can take -5 from your account, which means giving you 5. Money creation. It also existed in online banking. Okay. And so I crossed out the negative amount because it should be covered by the base threat model for the API. The base threat model should have the types defined in the system. So a type of an amount, or like maybe not an amount, but a wire transfer amount should not be negative. Okay, the last one. Users should be able to reset a password. And the reset password flow looks like this. You put your email in the system. To your inbox, there is the email with the reset password link, and the reset password link looks like this. So here is your email, and there is some random number. And when you click this link, there is the third step. You can set a new password, and you confirm the new password. How would you attack this? No, not so fast. Okay. Yep. Okay. Brute forcing or guessing the password number, the random link. Yep. Changing. Sorry. What? Replay attack. Yeah, that's a good one. What if somebody already used that token and tries to do it one more time? Remove the token from URL. Good. A lot of systems are vulnerable to that kind of attack. Yeah? Yeah, okay. So another way, a different way of guessing the random number. Change mail. So you reset password for somebody else, and then you change it to, you reset password for your account. It's your account, so you get the link with the random number, and then you change the email to somebody else's in the third step, which means that if there is no connection between the random number and the email, you could reset somebody's password, a very common vulnerability. Yep, yeah. Or some email spoofing or phishing, yeah, as well. Yep, good one. Yeah, apostrophe or 1 equals 1, yeah? Or a list, yeah. Good one. From the real vulnerabilities, I've also seen in the email field, put a comma and a second email. So the application which was written, I don't remember, I think Ruby or Java, I don't know, was taking the first email, resetting the password for the first email, and then it copied the email field into the mail library, which was sending an email, and it simply sent the CC to the second email. Okay. So there are a lot of these kind of attacks. And so we've got, you could also lock other accounts. You could brute force for the list. You could lock all accounts in the system if the system resets the password the moment you put your email. Get a copy that was mentioned, analyze and guess the contents of the link, yep. Use reset link against another account that was changing the email field. Bypass steps 1 and 2. You could do some attacks with that and change somebody's other passwords with the injections. And again, some of the test cases can be covered by the base threat model for the API itself, and they don't need to be modeled during the threat modeling. Cool. So this is more or less all I wanted to say about the idea how to introduce threat modeling. Now, a few closing words. Does it solve all of the problems? Well, no. all of the business type of logic errors can be predicted during the threat modeling. The base threat model cover most of the technical threats, but there are some threats outside the control sphere, outside the analyzed system. So, for example, if you use Stack Overflow, you copy some code from the Stack Overflow, right, to your Bash console. Imagine it or not. I'm sure somebody does it here. Yeah, retype it or copy it to Notepad, because believe it or not, between copying and code, here there is an invisible string of Bash exploit. And if you copy this to Bash, it will just run. Yeah, so these kind of bugs, they're not modeled during the threat model for the application that the developers are deploying or developing, but it is more or less a threat modeling for a company, or for the process of developing software. Presentation clickers, as I mentioned, like I could model, if I was a developer, I could model the threats, or even a pen tester, I could model the threats for my company, for the systems that I use. But then if I just connected this to my computer, you could practically pawn my computer. Okay, so that's the Logitech clickers. So to summary, well, shift left, that's, it's a common phrase, but I actually do it, and today I hope you learned how to do it and how it can be possible. So introduce some security back in the pipeline, not during the release, during testing, during the coding, during the design. Know your enemy, and that's what threat modeling is for, knowing who can attack your application. So for example, I plugged in the organizer's USB drive into my computer because more or less I knew that they're not my enemy, right? But what if they got compromised before and they just had a virus on their USB drive, right? Automate and centralize. You can save yourself a lot of time with centralizing the security mechanisms. Validating input. If you have a type, a class, a library that validates email, just allow it for downloading for all developers in your company, so that when they need to parse an email, when they need to parse an amount, when they need to parse a specific CSV file, they'll have a validator in the central database. Same with the single sign-on mechanisms. Give them the libraries and allow them to use it. And the same with centralizing you can achieve with the base threat models. And the earlier you introduce the changes, the better. Also, when it comes to the size of your company. If your company is 10, 20, or 50 people, it is much easier to start with some security initiatives. Because when your company gets up to like 1,000 people or 2,000 people, well, then you can't control. You would need to change the lives of a lot of people, and it's hard. So, call to action for today is: I would be very happy if at least, let's say, 5 of you, when you go back to your work, try to do some malicious stuff in your applications. Try to put apostrophes. Try to put script or XML into test cases if you're a tester. If you're an administrator, use password managers. Think what can go wrong if you're a developer, and simply ask your project owner, your architect for the security requirements. Like, how am I supposed to write it securely? What are the security requirements? Maybe then they will think about actually defining the security requirements. Thank you very much, and if you have any questions, I'm happy to answer.